parabolas exercise from Delta, the recent set of work you guys have been doing. So just having marked the work as it's been coming in, there's a few things I just noted down it might be useful for us to go through as a group. Really pleasing to see the way you're getting hold of all of this stuff through all the conic sections, and lots of really good work coming in. But a couple of things, as always, just to have a look at and just to bear in mind. So we're going to start off with question 4, part A. Okay, so what we have here, we've got a parabola and we've got to get its equation. Now we know straight off that we have the vertex of the parabola has moved. So rather than it being at the origin, it's at the point -4, 0. So straight away, that tells me that rather than it being y squared equals 4ax, that form, it tells me, because the x has been shifted, we're not any different than the y's, but it's going to tell me that it's 4ax minus a -4, so it's a +4, isn't it? Okay, 4x plus 4. So we know it has that form to start with, but we just need to find out what a is. Once we've got a, we've got the parabola. But we know a point, right? Quite often what comes up in these sorts of questions, what's going to come up in some of the questions I'm going to talk about on this video, is that we need to use points on the curve that we're given. All right, so you may not think we're given any more information, but we are. We know that this intercept here is 6, and we know this intercept down at the bottom is -6. Actually, when I square those values, I get the same thing, don't I? I get 36, it doesn't matter. So substituting either of them into this equation is going to give me the same thing, because the x value on the y-axis is 0 as well. Okay, the x value on the y-axis is 0. So I put in the point, let's just take the point 0, 6 then. Let's use that one to start with. I say it wouldn't matter if we use the other one, because when we square y, we get the same thing. So I've got 36 is 4a, and x plus 4, well, x was 0, yeah? So x plus 4 is 4, I end up with 16a then. 4 lots of 4a. 36 is 16a. Let's just divide that through. 4 will divide into both sides, so I get 9 is 4a. And actually at that point I can stop. I don't need to go any further and work out what a is, because all I'm being asked for in this question is to write down the equation of the parabola. That's all it's asking me for. Well, if I know what 4a is, I can just put 4a in my equation. That's going to work for me. So I can just say that the equation of this parabola is y squared is 9, equals doesn't come across very well there, it's 9 lots of x plus 4, because that's what 4a was, 9. And the x plus 4 just in the brackets there. And that's that question done. Okay, but we're going to come to this quite a lot, all right? I think one of the things that maybe just picking out from a number of you at the minute that we need to keep coming back to is this idea about using points on the curve. Use points that you know are on the curve and substitute them in to the equation. Okay, substitute them into the equation of the curve that we've got. We've got a point on it. Let's put that in, and that will help us then to work out any of the constants that we don't know. All right, so that's big thing really, just to watch for. So question 5 now, I'm going to have a look at part B. So part B here, question 5, all the question 5 is about using complete and the square, rewrite the equations so they look like the usual form of the parabola, y squared equals 4ax, and then draw the parabola. Okay, so we've got to get it into the standard form first, and then we're going to draw it. Okay, well, let's have a look at how we're going to do that. Let's swap over to my pen. So remember, I've said on these sorts of things before, group the terms together. So I'm going to put the y squared and the 6y together to start with. Okay, I want those two to go together to start with. I know the x terms are going to go across onto the other side, yeah, because the x's will go on the other side to the y squared. So let's deal with that straight off. Let's just take everything over onto the other side. Well, the -3x when it goes onto the other side will become a +3x, and the +12 will become a -12. Again, just be careful. Some of you going a little bit wrong at those stages where you're swapping stuff across onto other sides. We know if we've got to complete the square, we halve the coefficient. of the linear term, of the term in y here. Oops, for some reason I'm talking. I always struggle when I'm talking and I'm trying to do something at the same time. It's normally not a good idea. So we're going to get y plus 3, because we halve the coefficient of the y, squared is going to be equal to the 3x plus 12. But we've got to remember what else that square bracket has given us. That square bracket has also given us a plus 9. If I square the 3 at the end, I get a plus 9. That plus 9 wasn't there before, so I need to make sure I've got the plus 9 there too. So simplifying, I'm still going to get the y plus 3 all squared. And just simplifying the numeric term on the right-hand side, I'm going to have 3x minus 3, aren't I? That's what I'm going to be left with. So actually, if I want to give this now in the full form that I expect to see a parabola in, so I'm going to be able to say y plus 3 squared is equal to, and the 3 is a factor on the right-hand side, so let's just deal with that, 3 lots of x minus 1. That is given my parabola in the standard form. Okay, I can see from this, to help me sketch it, that the vertex of the parabola will now have moved to the point 1 minus 3 because of the offsetting I'm having happen in my equation above. With the y value, I'm subtracting minus 3. With the x value, I'm subtracting 1. I can see that. I can also see, if I wanted to, that my latest rectum length is going to be 3. Yeah? The latest rectum length is going to be 3. And actually my a value, because remember the latest rectum, the thing that goes here is 4a. Yeah, 4a in front of the x. So that 4a would have been 3. A is 3/4. This should give me enough to be able to sketch what the thing is going to look like. Okay, so let's start it out. So we'll get our axes on, usual axes, and we've got to think now that we know where our vertex is. It's at the point 1 and minus 3. So let's make that a 1 and a minus 3. And that's where my vertex has moved to. Okay, I know my focal length is 3/4. So I will move another 3/4 in this direction. Okay, another 3/4 in this direction to get to where the focus is going to be. So my focus will be just 3/4 further along, won't it? So, that's going to be 1 and 3/4, and my focus has moved along, and it's still on that position, 1 and 3/4 and minus 3. It's in that position. That's where my focus is. If I want to, just to be a bit better in terms of the sketch that I'm going to produce now, I could think, well, actually, where is this going to cross the x-axis? It's going to cross the x-axis somewhere, but can I be certain where it's going to cross it? It's going to cross it somewhere bigger than 1. Yeah? Is it going to cross it somewhere bigger than 1 and 3/4 though? Whereabouts out here is it going to cross? So where is it going to cross the line y equals 0? Well, put y equals 0 into our equation. Okay, y equals 0 is the x-axis. Remember, that's the thing to always make sure you got clear in your mind. Y equals 0 is the x-axis, x equals 0 is the y-axis. If I put y equals 0 in here, y plus 3 all squared, well, that'll just be 3 all squared, so it'll just be 9. It's going to be equal to the 3x minus 1. 3x minus 1. Okay, from the other side, y squared, y plus 3 all squared rather, is 3 lots of x minus 1. So that's my y plus 3 squared, and that's my 3x minus 1. So what's that telling me? It's telling me 3 is x minus 2 then, isn't it? Divide through the whole thing by 3. 3 equals x minus 1. And it's telling me then that 4 is x. So actually it does cut that x-axis quite a lot further along than here. Yeah, so if that was 1, I've got about 2, 3, 4. It's going to cut here. That's where it's going to go. Okay, so let's try and see how well I can get this. Here's my focus. Sorry, here's my vertex. Here's a point it goes through. This is probably not going to look fantastic. No, I've missed my 4, haven't I? Okay, this is where I cheat a little bit and now say that's 4. because I do know that's where it crosses. It is just a sketch. It doesn't matter too much, and I do struggle trying to do these things on the screen, but it's going to look like that. Okay, so that's all we need to do. Thinking about those sorts of things. Complete the square, but be careful as you go with your completing the square. All right, so that's question 5. But again, we've used the fact that we can bring something in that we already know about. Okay, we knew y equals 0 will help us find a point on the x-axis, so let's do that. It just gives us a better idea of what that curve's going to look like. Okay, question 6. So we've got another parabola here that is offset. Its vertex is going to have moved. We want to draw it, and we're going to write down on our sketch the coordinates of the point where it intersects the axes. So let's have a go at that then. I should know straight off from this that my vertex is -3, 2. Okay, I have to be a little bit careful, I admit to you on this. When I'm doing these questions with the parabola for the vertex, I have to be really careful that I don't get those the wrong way around. Because for me, I just start reading it. I'm used to seeing, we're dealing with the other conic sections. We're used to writing the x term first and then the y term. Really easy for me to write that down as 2, 3, rather than -3, because that's with the x, and the 2, because that was with the y. Don't know if that's a problem for any of the rest of you, but it causes me a problem every time. I have to think about it really carefully. What else do we know from here? Well, we know 12 is the length of the latest rectum. I know the focal length then is 3. Okay, because that thing is 4a, isn't it? Well, that gives me a start on my sketch. Okay, so my start on my sketch, and I'll put the other things on here in a minute, but I know I'm at -3 and 2 for the vertex. So -3 and 2 for the vertex. And I know that my focal length is 3. The distance from the focus to the vertex is 3. Well, if I move 3 along, I end up here on the axis, don't I? Yeah? So I know that's where my focus is. All right? So focus is in that point. It is actually on that axis. But we're going to get something else happening here. We're going to get a curve that does this. It's going to come round, go through, and then the symmetry is going to come back the other way. We're asked to find out in part B, where is that, where is that, and where is that? What are the 3 points of intersection on the axes? And then we can label those on. Well, remember again, the y-axis is x equals 0, and the x-axis is y equals 0. Let's start with y equals 0 first. All right, just because it's easier. Doesn't matter which way around you do them, but I'm going to start with y equals 0 first, because what I have to do y minus 2 all squared. Y minus 2 all squared, well, that's just -2 squared. That's just going to be 4. Equals 12, x plus 3. 12 lots of x plus 3. Okay, divide through by the 12 if I like, and I can say that's a third. 4 over 12 is a third, and that's x plus 3. Subtract the 3, and I've got my point of intersection there is going to be x is -2 2/3, because I've subtracted a 3 off a third, or if I like, -8 over 3. Okay, that is my intercept on the x-axis. So where's -8 over 3? It's here. Okay, -2 2/3 is there. All right, it's getting close onto the 3. -2 2/3. All right, for my intercepts on the y-axis is x equals 0. So I can use x equals 0, and I can say, put x equals 0 in there. So my y minus 2 squared, okay, y minus 2 squared is 12 lots of 3, because x plus 3 is just 3. 12 lots of 3. Well, that's 36, isn't it? 12 lots of 3, that's 36. Now, there's a really big temptation here to multiply out the y minus 2 squared. Try and avoid that temptation, because what we've got at this point is something squared, y minus 2, all squared, is 6 squared. Square root both sides. Okay, when you see something like this, where you've got something squared is something else, just square root both sides. You're going to get to where you want to be. So I can say y minus 2, but I just have to remember here that it's a plus or minus 6. Okay, I know I've got 2 points of intersection, haven't I? On the y-axis, I'll come back to my y-axis. I've got 2 points of intersection here and here. I should expect to get 2 answers for y. Well, if I square root, how do the 2 answers come out? Well, because I get a plus or minus 6 when I square root the 36. Okay. If I had the plus 6 there, I'll have to add 2 on. So the plus 6 adding 2 on will give me 8. If I had the minus 6, I've got to add 2 on. So that will give me minus 4. 2 on to minus 6 gives me minus 4. And then I'm kind of there, aren't I? I've got that's minus 4. And I've got that's 8. How else could we have figured this out? Well, actually, we've got the length of the latus rectum, haven't we? We know the latus rectum is 12. So if the latus rectum is 12, the latus rectum is the distance from here through the focus to here. That's 12. And it's symmetric. So here to here is 6. So if that's 2, that's got to be 8. Here to here has got to be 6. If that's 2, that's got to be minus 4. So we could have done the last bit with where is the intercepts on the y-axis without using this idea of x equals 0, but only because our focus was on the y-axis itself. If our focus was anywhere else, you'd have to do it this way. Okay, but just maybe a bit of a shortcut on that one. So there we go. That's question 6. Let's go on to the next. Right, so question 8 is asking us to write the equation of a parabola, and it satisfies a number of conditions. We've got a vertex at 1, 1. Our axis of symmetry is y equals 1, and we're told a point on the curve. This point on the curve bit again, okay? Like some of the earlier questions, the point on the curve is coming back. We're going to have to use that at some point. Let's get a little bit of a sketch. So if I do my little bit of a sketch, what's he look like? So I got my y-axis and I've got my x-axis. The vertex is at 1, 1. So let's just note that in there. The axis of symmetry, the line of symmetry across the parabola is there, y equals 1. So it's telling me it's going this way round, is it? Well, it could be going this way round, couldn't it? How do I know it's going? Let's bring that up so I can show my laser pointer. So how do I know it's going this way round rather than going this way round? Because both are possible. Well, I know that because I know that 2, 5 is on the curve. Okay, 2, 5 is on the curve. 2, 5, 2, 5 is out here. So it must have approached like that. All right, so you might have just assumed that and used it, but how can I justify it was this way around and not the other way around? Well, that's how. So I've got it coming in and I've got it doing that sort of a thing. And I've got 2, 5 is on here. 2 and 5 is on the curve. Okay. Now, I know because the vertex is 1, 1, I know that y minus 1 squared is 4a x minus 1 squared. So I've got that offsetting of the x and the y to take account of the vertex not being at the origin. But I know 2, 5 is on the curve. So I'm just going to use my point again. All right, so it's cropped up in a lot of questions, this one. And it's a big thing just to push on. Okay, using the point and substituting into the equation of the curve. That way we can see what a is going to be. So I've got to put 5 in for y. So I'm going to get 5 minus 1. That's 4. Square it, 16. Thank you. Equals 4a multiplied by x minus 1. Well, x minus 1 is 1. So 4a is 16. Well, I've done that, haven't I? because all I need to know is what is 4a. My length of my latus rectum goes there. And 4a is the length of the latus rectum. So I can just write y minus 1 squared equals 16 x minus 1. And that is the equation of the parabola that satisfies the conditions. The vertex is at the point 1, 0, at 1, 1. The axis of symmetry is y equals 1. And 2, 5 lies on the curve. That is our parabola. Okay, hope that's helped on question 8. Question 9 then. So this question is about parabolas that have a vertical axis of symmetry. Right? So what it's telling us is our axis of symmetry is in this direction, parallel to the y-axis, rather than parallel to the x-axis, like is our standard form, isn't it? We're used to seeing it that way round. This one is going the other way round. Okay? We've got to find out where the vertex is, get the focal length, the coordinates of the focus, the length of the latus rectum, and then draw the graph. Okay? Final question. This one was on the homework. So let's swap over to using our pen. Oops, I seem to be losing the ability to get that. Right, okay. So we're going to have to work with completing the square. And this time, because it's the other way around, the typical form centered on the origin would look like this. X squared is 4ay. All right, just swaps over, doesn't it, the x and the y, because we're now looking at something that is symmetric vertically. So we're going to have to deal with the fact that we don't just have x squared in our equation that we're given. We've got this x squared minus 4x, plus 4x and the minus 5. All right, and the y term and everything else we need across the other side. So let's just start with that. Let's come back to the pen, and I'm just going to start by just putting the x squared bits plus 4x, and then everything else across the other side. Again, be careful when you're taking stuff across the other side. Yeah, the y was already there, but that minus 5 is going to become a plus 5, isn't it, when it goes across the other side? Okay, if it's a minus 5 with the x squared, it's a plus 5 when it goes to the y. Complete the square. X plus, 2. That is the worst plus I've ever drawn. X plus 2 all squared equals y plus 3. But that plus 2 at the end of our squaring bracket, that plus 2 there, when it gets squared, it brings out another 4, doesn't it? Brings out another 4. So we need to put another 4 onto the other side, otherwise it will not remain in balance. So what have I got? I've got x plus 2 squared is equal to y plus 7. Oops, didn't mean to go back there. Apologies for that. Where am I going? Jumping about a lot there. Equal to y plus 7. Okay. So that is now in the standard form because we've got something involving x being squared, and we've got something involving y, okay, that is then being multiplied up. If we wanted to, and if it just makes it easy for you to think about this, this is one lot of y plus 7. Why have I done that? Just because it might make it easier for some of you if you're struggling to see what the length of the latus rectum is. The length of the latus rectum is the thing that appears in front here, isn't it? 4a is 1, so my latus rectum's length is 1. My focal length, a, is always a quarter of that, because remember that's 4a is the length of the latus rectum. So the latus rectum, it's 1. The focal length is a quarter. And the vertex of this one, if we look at what's happened, this time I don't have to worry about the fact I sometimes write these the one way around, because x is first and y is second. But remember, it has a vertical axis of symmetry, this one. So let's just check the question. Have we answered all the bits that we need to do? Yeah, we haven't sketched it yet, but let's have a look. The coordinates of the vertex, yes, we've done that. The focal length, Yes, we've done that. Oh, coordinates of the focus, we haven't done that, but we did do the length of the latest rectum. So the coordinates of the focus, okay, because of which way round this is going to go, because that's a positive in there as well. So let's just get this out right and get my pen. So the coordinates of my focus, what's happened? My focal length is a quarter. So I'm going to move a quarter up. Remember, we're in the vertical direction here because of our axis of symmetry. So I'm going to move a quarter up from where I was. I was at -7. I'm going to move a quarter up. So it's going to be -2, a quarter up if we like. We'll leave it as a -6 and 3/4 will be my focus. All right, let's just have a bit of a sketch then, because I think we've got everything in there. Draw the graph, sketch it out. So we've got our axes. We've got our vertex is at -2, -7. So I might choose a bit of a smaller scale on my y-axis, just so it fits on nicely. I know that this is my axis of symmetry because my axis of symmetry has to go through the vertex, okay, and it also so there's my vertex, isn't it? There, it has to go through my vertex, and also I know that it was a vertical axis of symmetry. Okay, so it's going through my vertex, and it's a vertical axis of symmetry, and I know that my focus was at this point -2, -6 and 3/4. It's really not moved very much up there. Okay, that's, that point there. Let me just write it over this side because I'm going to struggle with my PowerPoint writing to get the -6 and 3/4 written in. So that's there where it's stepped up, and I'm going to get my parabola comes down, hits, okay, and is going to come back up. I wasn't asked on this one where it intercepted, okay, on any of the axes, but I could do exactly the same things I've been doing before. Okay, why not do it just to finish off with? Let's finish with a bit of flair. So to say where it's going to cut the y-axis, we could put x equals 0. If x is 0, what do I get? I get 4 is y plus 7. All right, look at the equation that we got. We've got x plus 2 squared. Well, that's just going to be 2 squared is y plus 7. That's what we were looking at. Let me just flip back so you can see. You can't see which bit I'm talking about. X plus 2 squared is y plus 7. So my x plus 2 squared is y plus 7. Not very difficult to work out from there then, is it? What we're going to get for our value for y is going to be -3. Okay, so if I wanted to be concerned about where this point is here, actually mine looks quite close to -7. Actually, it's coming up a lot steeper, a lot quicker than that. Okay, so mine's a bit flatter. It probably ought to be, and not that they'd worry too much about this, but it probably ought to be done a little steeper so it comes up more quickly. Let's find then our intercepts on the x-axis. So the x-axis is y equals 0. So if I'm going to put y equals 0 in, I can say that x plus 2 squared has got to be equal to 7. Yeah, y is 0. So if I like then, x plus 2 is square rooting both sides, remember? Well, I can't square root 7 easily. I'm going to have to leave it as plus or minus root 7. So x is -2 plus or minus root 7, rearranging that. Now, the way I've got my graph drawn, it looks like one of these intercepts will be positive and one of these intercepts will be negative. Yeah, it looks like I've got a positive one out here and a negative one out here. If it went really steep, yeah, I might get 2 negatives, might I? So my graph could look a little wrong. I could get 2 negatives. But if it was going to do that too, remember, it's going to be that steep, then wouldn't that mean my y-intercept would have to be positive as well? Yeah, I can't have that negative and this one stay down here. It doesn't make any sense. Yeah, they have to bounce back. So I have got them in the right place, and just to sort of think about it a little bit, root 7, well, that is less than the square root of 9, but it's bigger than the square root of 4, so it's bigger than 2. Root 7 is bigger than 2, it's less than 3. It's bigger than 2, it's less than 3, so we will still be positive. Okay? Bigger than 2, so it'll knock out the minus 2 when I add it on, and it will make it positive. Hope all that's helped. Big thing, remember guys, going back to these ones, the ones I really want us to make sure we're making better use of in some cases, is this idea of using the point. If you know a point on the curve, put it into the equation. You can then use that from there, and it should make the question a lot easier. Hope that's been helpful. See you next time.